Right, 5.3 is graphing square root. So if we wanted to look at y equals the square root of x, we'll have to be able to graph that. This is called the parent graph because it's the most basic graph you can make, y equals square root of x. If I wanted to find the domain of it and the range of it and make a sketch, those are three things that we'll have to do. Now, generally, when we're graphing, we'd make a table if we don't know how to graph it or what the shape is. So usually I recommend to start our table at -3 to 3, something like that, just to see, you know, in that region what it looks like. So if I plug in -3, the square root of -3 is not a real answer. So there's no answer. -3 is not a part of the domain. In fact, -2, -1 is not. So we would start our x values at 0. That's the first value in our table. The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is some decimal. Square root of 3 is some decimal. So if I'm going to just pick numbers that work out nicely, I'm not going to use 2 and 3. I'm going to go 0, 1, and then the next number that works nicely is the square root of 4. The square root of 4 is 2. And then we could go all the way to 9 because that's the next perfect square. The square root of 9 is 3. So if I'm making a table for y equals the square root of x, I'm going to start at 0, 1, 4, 9, and use 4 values. So 0, 0, 1, 1, 4, 2, 9, 3. So if I was going to plot so x is 0, 0, 1, 1, 4, 2, 9, 3. You can see it's not a straight line. It's actually curving like this. So this is half of a sideways parabola if I drew it correctly. So imagine that the whole parabola would be like that. It's just the top half of a parabola sideways. So the domain, remember domain is possible x values. The first possible x value would be 0, and any number beyond that would be okay, but nothing negative. So if I was going to say the domain, it would be x greater than or equal to 0. And then the range is the possible y values. Well, this will never go down below the x-axis. Okay, so our first possible y value is right here, and then it goes up from there. So like on the y-axis, what are we working with? We're working with this, and then it goes on forever. So the range would be y is greater than or equal to 0. Okay, so this right here is called the parent graph, as I said. So the parent graph of anything is just like the most basic equation you can come up with. I'll give you another example. So if we're going to find sketch, domain, range of y equals the square root of x plus 3. Okay, so the first thing we always have to do in order to start our table, it's whatever makes the inside of it 0 is our first x value. Can somebody tell me what the first x value will be in here? Because it's what makes the inside 0. What are we going to start with? What's going to make the inside 0? What number?
0.
Well, if I plug 0 in for x, you get 0 plus 3, so that's not 0. So what will be, what if you add, what when you add to 3 will give you 0? So -3, very good. So we're going to start our x value. Our first point is going to be -3. Okay, in this first ordered pair, if I plug -3 in, I get 0. Square root of 0 is 0. This first order pair is very important. Okay, This is going to be the start of our graph. It's going to indicate where our domain begins and where our range begins. So this is it's the end point of our curve. Okay, so it's the most important point of all of these. Okay, so now our pattern is we went up to get perfect squares. We went up 1, and then we went up 3, and then we went up 5. And if we wanted another perfect square, we could go up 7. But 4 points is sufficient. So we're going to go up 1, and then up 3, and then up 5 to get the x values that are going to work for us. The other ones will work, but these are the easiest ones. So -3 plus 1 is -2. -2 plus 3 is 1. 1 plus 5 is 6. So those are my x values. So this -3 is where we start whatever makes the inside 0. -3 plus 3 is 0. Then I go up 1, up 3, up 5. So now we're set. If I plug -2 into my table, or into my equation, -2 plus 3 is 1. Square root of 1 is 1. If I plug 1 in, 1 plus 3 is 4. Square root of 4 is 2. Plug 6 in, 6 plus 3 is 9. Square root of 9 is 3. So we should get, as long as there's not a number out front here, we should get 0, 1, 2, 3 every time if we did it right. Alright, so we're going to make our sketch. My first point is -3, 0. My next one is -2, 1, 1, 2, and 6, 3. Same shape. So if you're going to compare these two, what did the x plus 3 do to my original parent graph? Which way did it move it? It moved it left. Very good. It moved it left 3. Okay, so this is kind of consistent with what we did in parabolas. If you had x plus 3 inside the parentheses for a parabola, that would move it left 3. Alright, so if we're going to figure out if this was -3, it would have moved it right 3. So the domain for this one, our graph starts right here and it goes forever to the right. So it starts at -3 and x has to be greater than or equal to -3. And the range is based off of that one. It's got to be y is greater than or equal to 0. Okay, so this is where the domain starts, that is where the range starts. So why don't you try making a quick sketch and finding the domain of y equals square root of x minus 2. I'm going to pause the recording. Alright, so our table is starting at 2 because if you just set x minus 2 equal to 0 and solve, you get 2. So that's what's going to make the inside 0. So if I go 2, then I have to go up 1, so that's 3. Up 3 is 6. Up 5 is 11. So those are my x values I'm going to use. They're going to make nice even answers for us. If I plug 2 in, square root of 2 minus 2 is 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Okay, so now plotting the points. 2, 0, 3, 1, 6, 2, 11, 3. Domain, it's going to be greater than or equal to 2, and the range should be greater than or equal to 0. Alright, so do you see where you can raise your hands? Let's see. Raise your hand if you got that right, or at least most of that right. Alright, so we got a few. Alright, well, for the first try, that's not bad. Maybe a third of us got that right. Let's try a little bit different. Okay, so same thing. I want you to make a table. I want you to sketch. I want the domain and the range. So 4 points again. Now it would be tempting to choose -3 as your first x value, but we're only looking at the square root. What is going to make the square root 0? And what would that be? What will make that square root 0? It rhymes with hero. So you don't have to say it, I'll say it for you. Okay, so 0. Thank you, Noah. Okay. Alright, so 0 is going to make that. So -3 doesn't work because we're taking the square root of that number. So 0 is your first x value. See if you can complete the table and the problem. I'll pause it here. Alright, so we're going to start at 0. We're going to go up 1, up 3, up 5. If I plug it in, square root of 0 is 0, plus 3 is 3. Square root of 1 is 1, plus 3 is 4. Square root of 4 is 2, plus 3 is 5. Square root of 9 is 3, plus 3 is 6. Alright, so there's our table. So we can start our graph at 0, 3. 1, 4, 4, 5, and 9, 6. So again, it's the same shape. This plus 3, since it's outside of the square root, moved it up 3. The whole graph just shifted up 3. So if I was going to find the domain, looking at this, it has to be x is greater than equal to 0. And then the range, y is greater than equal to 3. So domain starts here, the range starts here. Y values, they're all at or above 3 right here. There's 3 and it goes up above it. So far so good. Alright, so I'm not going to give any more I'm not going to make up any more examples. I'm going to have you try this exploration, and you don't have to pull it up on your, like I attached it to your assignment, but there isn't that much to it. See if you can graph these 4 equations with these 4 graphs. And we haven't talked about the negatives, but maybe you can figure that out by exploring. So why don't you, based on the equation, see if you can figure out, match up the graphs. I'll give you a couple minutes to do that. Alright, so looking at square root of x plus 2. That plus 2 on the inside the square root is going to move it left 2. And it does not get shifted up or down. It's not opening down because it's a negative. So let's see. That looks like it will be A because it shifts it left 2. There's no number out front. That would make it a skinnier or a more steep graph. So A is A. B, this x minus 2 will move it to the right 2. So that looks like D. This one has 2 things going on. It goes left 2. That's what the plus 2 on the inside does, because its first x value is -2. So that moves it left 2 and then down 2. So left 2, down 2 would be B. And this plus 2 still moves it left 2, but then kind of like parabolas, if it's a negative it's going to flip it. So it's going to be C. It'll open down. So based off of the graph or the equation, we could say that the domain of this one, it starts right there. Domain is greater than or equal to -2. And the range is greater than or equal to 0. Because it starts right there and goes up. See if you can figure out the domain and range. Why don't we, you can do B, C, and D. Give it a shot. That's a little bit more difficult, but see if you can do the domain and range of B, C, and D. Alright, so for B, trying to find the domain, it starts right there. So the first X value looks like it begins at -2 and it goes forever to the right. So the domain of this one would be X is greater than or equal to -2, and the first Y value starts down here at -2 and then goes up forever. So that point right there, -2, -2, is the most important. The range will be greater than or equal to that point, so greater than or equal to -2. For C, if I wanted to find the domain of this, it would be starting at -2 and going forever to the right, so greater than or equal to -2. The range starts at 0, but then it goes down. It's all values less than or equal to 0, so Y is less than or equal to 0. And lastly, D, the domain starts at -2 and goes forever to the right, so greater than or equal to 2. Starts at 2, I don't know if I said -2, but it starts at 2 and goes to the right. The range is at 0 and goes forever up, so Y is greater than or equal to 0. Questions on graphing square roots? So I would want you to make a table. We can always graph them on our calculators. I mean, it does it for us. We aren't learning much, but you could do the square root of x plus 2. So we know that this is A right here, based off of the graph in the calculator. So you can always double check with your calculator to make sure you drew the sketch correctly.